Based on the information, the wiring in the 24 volts alternating current control panel can be classified as Class 1 in accordance with Section 725.21 of the 2002 National Electrical Code, also known as the NEC. Class 1 circuits are defined as circuits that are not power limited and are used for signaling, control, and communication purposes. Consider the application and components within the control panel. The 24 volts alternating current control wiring is used to control various devices such as limit switches, push buttons, motor starters, solenoids, and alarms. This suggests that the circuits are not directly involved in the primary power distribution system, which includes the 115 volts alternating current or the motor voltage. To ensure proper installation and safety, it is crucial to verify and adhere to the NEC guidelines along with any other applicable electrical codes or standards. Firstly, determine the appropriate wire types for the control circuits, taking into account the voltage rating, temperature rating, and environmental conditions. Secondly, select suitable conduit or raceway systems to protect the wiring from physical damage and environmental factors. Thirdly, implement proper grounding and bonding practices to minimize the risk of electrical shock and ensure equipment safety. Fourthly, ensure that all wiring connections are made securely and properly terminated to prevent loose connections or arcing. Fifthly, label all wiring and components clearly to facilitate easy identification and maintenance. Sixthly, verify that the control panel is adequately ventilated to prevent overheating of components. Seventhly, conduct regular inspections and maintenance to identify and address any potential issues or hazards. To elaborate further, the classification of Class 1 circuits is important for understanding the safety requirements and installation practices for the wiring within the control panel. These circuits are not power limited, meaning that they can carry higher levels of current and voltage compared to Class 2 or Class 3 circuits. As a result, Class 1 circuits require more stringent safety measures to protect against electrical shock and fire hazards. To delve deeper into the selection of appropriate wire types, the NEC provides specific guidelines for the type of wire to be used based on the voltage rating, temperature rating, and environmental conditions. For example, for 24 volts alternating current control circuits, conductors with a minimum insulation rating of 300 volts may be required. The choice of wire type also depends on the ambient temperature and the presence of moisture or chemicals. In terms of conduit and raceway systems, these provide mechanical protection for the wiring and help to contain any potential electrical faults. The NEC specifies the types of conduit that are suitable for different applications, such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit. The selection of the appropriate conduit type depends on the environmental conditions and the degree of physical protection required. Grounding and bonding are critical for ensuring electrical safety and minimizing the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for bonding metal enclosures and equipment. Proper grounding and bonding help to create a low impedance path for fault currents, which allows protective devices such as circuit breakers or fuses to quickly trip and disconnect the circuit in the event of a fault. Secure wiring connections and proper terminations are essential for preventing loose connections, arcing, and overheating. The NEC specifies the methods for making electrical connections, such as using wire connectors, terminal blocks, and soldering. All connections must be made in accordance with the manufacturer's instructions and torqued to the proper specifications. Clear labeling of wiring and components is important for facilitating easy identification and maintenance. The NEC requires that all electrical equipment be labeled with its voltage, current rating, and other relevant information. In addition, it is helpful to label each wire and component with its function or destination. Adequate ventilation is necessary to prevent overheating of components within the control panel. The NEC provides guidelines for the amount of ventilation required based on the heat generated by the equipment. Ventilation can be provided by natural convection, forced air cooling, or liquid cooling. Regular inspections and maintenance are essential for identifying and addressing any potential issues or hazards. The NEC recommends that electrical equipment be inspected on a regular basis to check for loose connections, damaged wiring, and other signs of wear or deterioration. Any problems that are identified should be corrected promptly to prevent further damage or safety hazards. By adhering to these guidelines and best practices, you can ensure that the wiring in the 24 volts alternating current control panel is installed safely and in accordance with the NEC and other applicable electrical codes or standards. In addition to the general guidelines discussed above, there are some specific requirements for Class 1 circuits that should be taken into account. Firstly, Class 1 circuits must be protected by overcurrent devices such as circuit breakers or fuses. Secondly, Class 1 circuits must be installed in a manner that prevents them from coming into contact with other circuits or conductive surfaces. Thirdly, Class 1 circuits must be clearly identified as such. Fourthly, Class 1 circuits must be installed in accordance with the manufacturer's instructions. Firstly, overcurrent protection is essential for preventing damage to the wiring and equipment in the event of a short circuit or overload. The NEC specifies the size and type of overcurrent devices that are required for Class 1 circuits based on the ampacity of the conductors. Secondly, preventing contact with other circuits or conductive surfaces is important for minimizing the risk of electrical shock. Class 1 circuits should be installed in separate raceways or enclosures from other circuits, and they should be properly insulated to prevent accidental contact with conductive surfaces. Thirdly, clear identification of Class 1 circuits is important for facilitating easy identification and maintenance. Class 1 circuits should be labeled with the words Class 1 circuit or similar language. Fourthly, installing Class 1 circuits in accordance with the manufacturer's instructions is important for ensuring proper operation and safety. The manufacturer's instructions provide detailed information on the proper installation techniques, wiring methods, and safety precautions for the specific equipment being used. Furthermore, it is beneficial to understand the distinction between Class 1, Class 2, and Class 3 circuits. Class 1 circuits, as mentioned earlier, are not power limited and are used for signaling, control, and communication purposes. Class 2 circuits, on the other hand, are power limited and are used for low power applications such as doorbells, thermostats, and low voltage lighting. Class 3 circuits are also power limited, but they have higher voltage and current limits than Class 2 circuits. The classification of a circuit depends on its voltage, current, and power characteristics, as well as its intended use. The NEC provides specific guidelines for determining the class of a circuit based on these factors. Understanding the different classes of circuits is important for selecting the appropriate wiring methods, overcurrent protection, and safety precautions. For instance, Class 2 and Class 3 circuits have less stringent requirements than Class 1 circuits due to their lower power levels. However, it is still important to follow the NEC guidelines for installing these circuits safely and properly. In the context of the 24 volts alternating current control panel, the Class 1 classification indicates that the circuits are not power limited and require more stringent safety measures. This means that the wiring must be properly protected by overcurrent devices installed in a manner that prevents contact with other circuits or conductive surfaces, and clearly identified as Class 1 circuits. It also means that the wiring must be installed in accordance with the manufacturer's instructions and any other applicable electrical codes or standards. By following these guidelines and best practices, you can ensure that the wiring in the 24 volts alternating current control panel is installed safely and reliably. In addition to the technical aspects of Class 1 wiring, it is also important to consider the regulatory requirements that apply to electrical installations. The NEC is a widely adopted code that provides minimum safety standards for electrical installations. However, it is important to note that the NEC is not a law unless it is adopted by a local jurisdiction. Many cities, counties, and states have adopted the NEC as their electrical code, with or without local amendments. It is essential to check with the local authorities to determine which electrical code is in effect in your area. In addition to the NEC, there may be other applicable electrical codes or standards that you need to comply with. For example, if the control panel is installed in a hazardous location such as a chemical plant or a refinery, you may need to comply with the requirements of the National Fire Protection Association, also known as the NFPA 70E standard for electrical safety in the workplace. It is also important to be aware of any industry-specific standards or guidelines that may apply to the control panel. For example, if the control panel is used in a manufacturing facility, you may need to comply with the requirements of the Occupational Safety and Health Administration, known as OSHA. Complying with all applicable regulatory requirements is essential for ensuring the safety of workers and the public, as well as for avoiding potential fines or legal penalties. In summary, the classification of wiring in a 24 volts alternating current control panel is Class 1 in accordance with Section 725.21 of the NEC indicates that the circuits are not power limited and require more stringent safety measures. It is important to select appropriate wire types, conduit systems, and overcurrent protection devices, as well as to implement proper grounding and bunting practices. Additionally, it is crucial to comply with all applicable regulatory requirements, including the NEC and any other local or industry-specific standards. By following these guidelines and best practices, you can ensure that the wiring in the control panel is installed safely, reliably, and in compliance with all applicable codes and standards. Remember to consult with a qualified electrical professional if you have any questions or concerns about the proper installation of electrical wiring. They can provide valuable guidance and expertise to ensure that the electrical installation meets all applicable requirements and is safe for its intended use. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Furthermore, regularly review and update your knowledge of electrical codes and standards to stay informed of any changes or revisions. The electrical industry is constantly evolving, and it is important to stay up to date on the latest requirements and best practices. This will help you ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and standards.